Okay. So let's talk about what this means. Another name, a shortened version of I can rearrange equations to highlight a variable of interest, is called literal equations. Okay? And in order for us to kind of talk about literal equations, I want you to think about what the word literally means. People literally use the word literally very wrong. So like if you were to say, I am like literally starving. No, you're hungry. You're not literally starving, because if you were literally starving, you would be sustaining on 1 cup of rice a day and nothing else, right? Okay? I'm literally like on fire. I'm so hot. No, you are not literally on fire. Flames are not shooting out of your body. You are literally means it's literally happening. Okay? So when next time you hear people say that word, I want you to think about what that means. No, you're not literally starving, okay? I'm so frozen, I'm like literally freezing. No, you're not. Your body is not an ice cube, okay? So you get the point? However, when we solve literal equations, we are doing just that. We are literally solving equations just for the sole purpose of solving an equation. The homework assignment that you just completed where I had you solving equations, those were not literal equations. Those were equations that had a purpose. The purpose was, I need to find out how much it costs per ticket. Or I need to find out the width of that rectangle, right? So there was a reason behind that. So a literal equation has you just rearranging things in the equation just for the sole purpose of learning the steps to that. So, for example, if I were to give you the equation, A plus B equals C, and there's no story behind this. There's no A is apples and B is bananas. All I'm asking you for is to solve this equation for the variable A. Why? Just because. There's no meaning. I just am asking you if you are able to manipulate these equations around correctly. And here's why. There was a question on the last quiz we took that was 16a equals 32 or something like that. And I had people subtracting 16 from both sides and telling me that A was, 16. And that's not true, is it? The opposite of multiplying by A or by 16 is not to subtract. It would be to divide, right? By a positive 16. So if you are able to understand how these equations are solved, then you will be fine with literal equations. So the concept of solving equation literally just for A means if I want A by itself, B is in the way. So I need to cancel out B. And how do I do that? Dylan. Yes, I just subtract B from both sides, and I'm left with A equals C minus B. And there's nothing else I can do with that. C and B are not like terms. I can't combine them. I'm not telling you, all right, now C is 8 and B is negative 2. Nothing else. That is your answer. You solved for A, you highlighted a variable of interest, and that's the answer, basically, okay? What if I asked you to take A plus B equals C, except this time not solve it for A, but solve it for B? So I am literally just asking you if you understand what steps it takes. So this time I want B by itself, which means A is in the way. And now I want to cancel A out. So let's subtract A from both sides. And B is highlighted, and you have C minus A or negative A plus C, right? Either answer is acceptable. Okay? So this learning target makes it sound a lot harder than it really is. You're just kind of manipulating equations and rearranging them. So that was an addition. Let's talk about this formula. We saw that formula in our homework yesterday, right? The area of a rectangle is the length times the width. If you know the area and one of the lengths or widths, you just divide by it to find the other. So what if I'm asking you to solve this equation for width? That means that the length is in the way, right? So I want to cancel that out, and the area divided by the length will give you the width. But you knew that, right? I could also ask you to take the area equals length times width. and solve it for length instead. And this time I would divide by width. Okay, so A over W equals L. All stuff that you kind of knew, right? Yeah, Josh.
What if we have to solve for C?
In which problem?
For A plus B or C.
It's already solved for. Solved for, the question was, what if we have to solve for C? And C, solving for a variable means on one side of the equations or equal sign, it's all by itself. So C is already solved for, okay? So let's take this science formula. Do you guys understand what F equals MA stands for in science? Maybe this is an 8th grade topic. It's force equals mass times acceleration. Force meaning the force at which something hits you, okay? That can be calculated by the mass of the object that is hitting you times the acceleration of that object. If I take a balloon and drop it on your head from 2 inches, there's not much mass to it and it didn't really accelerate, right? So is the force going to be very great? No. If I take a brick and stand on the top of a building and drop it on your head, it's pretty heavy and it's going to get some speed, the force is going to be higher, right? So that's what F equals MA means. Well, what if I know the mass, but I want to know the acceleration? So solve it for M. That just means divide by the acceleration. And the mass of an object is equal to its force divided by its acceleration. It's all just kind of manipulating equations, okay? So do you understand how that works? Force equals mass times acceleration. Just manipulate it around, okay? So far we've only just done one step, so let's do another one step. Let's take A over X equals Y. And you know what? There's no meaning behind this equation. It's just I just chose a bunch of letters and set it up in a division equation. And now I'm asking you to solve for A. Yes, you multiply each side by X. And the reason being is, if you have a fraction and you want to cancel out the fraction and the part of it that's in the denominator, you want to put it in the numerator because that cancels. And A over 1 is just A. And then usually you'll put your answer in alphabetical order. But multiplication is commutative, so I won't be picky as long as you get it right there. Okay. A little different story if you're being asked to solve for the bottom number. So you have a couple options here. Option 1 would be to go ahead and you're solving for X, which means you could just cancel it out over here like we did in the first step. And I would have A equals XY, but then I wouldn't be done. I would just have to take it one step further and do what next? If I want X by itself, I need to divide both sides by Y. And so A divided by Y equals X. Here's another option. AX, looks like a 9, equals Y over 1. And isn't that a proportion? And can you solve proportions by doing cross products? A times 1 is A. Y times X is XY, which is what we got to there, and then same deal. So you could either solve a proportion or just cancel it out first, get it to the other side, then get rid of it. Okay? Easy enough on that? So that was one step, literal equations. Let's take a look at AB plus C equals D. AB plus C equals D. Let's solve it. We're going to solve it for A, then we're going to solve it for B, then we're going to solve it for C, and it's already solved for D, right? So let's solve it for A first. And when you see this equation, I just want you to think of equations like this. If you can solve this equation, you can solve this one too, right? Because if I'm just solving for one of these, first I cancel out the constant. So if I would divide or subtract 7 here, I'm going to subtract C here, right? That's going to leave me with AB equals D minus C, or negative C plus D, however you choose. I just always write the top one first. And if I'm solving for A, that means B is in the way and needs to go. And now at this point, A is by itself. You have a couple of options here. You could leave your answer as is, because that's right. You're looking at your answer. You may just want to recopy it. So this is correct as is. But what I also want you to know, and you're going to need it in another couple examples, understand that when you have an expression in the numerator and just a single term in the denominator, each of these numerators can just be divided by the denominator. Meaning you could make it D over B minus C over B. So it's like they could either just share the B or they could each have the B separately. You probably won't see the answer like that very often. It'll mostly just be like that. But this is helpful to know for when we get to our next problem. Everybody okay with that? So if I were to solve for B, wouldn't I do the exact same thing except just divide by A instead? Do we need to do that one? Nah. Let's solve it for C though. Okay? And I know what you're thinking. You're thinking, well, this is all multiply, so I probably should divide by this. But here's the thing. You do the opposite of what's being done to the variable. And you know what I'm doing to the variable? I'm adding an AB to the C. So what's the opposite of adding an AB? Subtracting it. So you're going to actually want to subtract the AB here and not divide like you would think. So it's all about what is being done here. So C is equal to D minus AB. And that's a perfectly acceptable way to keep it. Okay? Now, if I were to take A over B minus C equals D, let's solve this one for A. So what are you thinking? Always, yep.
Add C.
Add, good. Add C. That gives me A over B is equal to D plus C. This is a little tricky because when I go to multiply both sides by B, I have to look over here, and would it be okay to just put a times B right here? No. Because by just putting a times B right here, that means I'm only multiplying the C times B, right? So if I'm doing this, I need to multiply the whole thing by B. And A is equal to B times the quantity D plus C is one way to write it. What do you think else would be an acceptable answer? A equals, Josh?
A equals B times C plus C.
Yep. You'll probably, again, see it just like this instead of this way. But that either way is okay. Got it? Okay? The last one, actually I have two more. So let's take a look at this. A plus Y over G equals X. And I want you to solve it for A. Okay. Here's your hint. If there's a fraction, you want to try to get rid of that fraction. And the easiest way to do that is to get rid of the denominator, right? So what am I going to do to both sides? Brandon. Yep. Multiply it by G. Because that gets rid of the G there. And that leaves me with A plus Y equals GX or XG. I just put it in alphabetical order. And I'm solving for A, so then I do what? Dylan?
Subtract Y.
Yep. And that leaves me with A equals GX minus Y. Easy? Okay. One more problem. If I were to take negative, let's do positive, 15x plus 5y equals 20. Okay. This is the first problem that we have numbers in it, right? We just did this on our bell work. We solved an equation for y so we could graph it, right? Because isn't slope-intercept y equals mx plus b? Remember that? So in order to graph an equation, solving it for y is your best bet. Well, this y has got a 5 and a 15 all around it. So what do you think we have to get rid of first? We're always going to save the divided by last. So it's whatever else is being added to it. So let's subtract 15x. Not divide, subtract it because it's being added. That leaves me with 5y equals 20 minus 15x, right? Almost home free. I have to still do what? Divide both sides by 5. And now, here's what we have. We have a little bit of what looks like a mess over here. Remember on the previous example I showed you, I said it was okay to leave the answer like d minus c over b, but you could divide each. Why wouldn't I really want to divide? Because they're not like terms and they can't, well, they don't need to be like terms. It would just be a big mess. Would it be okay to divide these? Because 5 does go evenly into each of these. So 20 divided by 5 is 4. So you could write it like this, or you could just do each of them. 20 divided by 5 is 4. What's a negative 15x divided by 5? Negative 3x, and that's your answer. The way that you'll probably see it the most is negative 3x plus 4, and that's your y-intercept, right? Okay? Now, they may not always be that neat. Okay? Bless you. We'll make this a plus. So, first thing I would do is subtract the 2x, which is going to give me 8y equals 6 minus 2x. Then I would divide by 8. And we have to do a little bit of thinking here. Because the last problem, man, it was nice. 5 went evenly into both of those. But 8 doesn't go into 6. Only a fraction of 8 goes into 6. Only a fraction of 8 goes into 2. You can only fit a quarter of 8 into 2, right? Which is why 2/8 is a quarter. So what is 6/8 reduced to? Right? And what does negative 2x divided by 8 give you? Right? So that is your answer. It's not pretty. Looks kind of messy. Looks kind of sloppy and ugly. Ugh. Because you're so used to, ooh, x equals 5, x equals 2. Woohoo, nice whole number. I'm done. This is not this lesson. Okay? So you have to be able to tell what equation variable it's asking you to solve.